Hi, I'm Raj Vijay Singh. I welcome you all to Mathscriber. In this video, I'm talking about domain, range and codomain of a function. First of all, what is a function? Function is a special relationship where each single real input has a single real output. Now that definition is really important. First of all, I will explain the basic concept of functions and later I will do few examples about finding domain and range of a function. Before we start, I must say if you are fond of learning advanced math stuff, please click like and subscribe, and to get to know my LL classes, visit mathscriber.com. So here we go, let's get started. Function is a mathematical machine which gives us real outputs. Now let's consider y equals x plus 3. Now we can consider this as a function. So now for each input we give for x, this machine will give us an output for y. Now this is, let's say, x plus 3. So now it will give the output y. So and for an example, you put the input 2. Now it will process in this machine, which we call function 2 plus 3, and it will give the answer 5. Now these values we are putting, we call them independent variable. Independent variable. Now these values we can't control. The function itself decide which to be given. So these values what we get from y we call dependent variable. Now all the values that we are allowed to put for x as inputs, we call this special name domain. Domain is all possible inputs that can go inside this x. So that's what domain is, and all the possible outputs that you can have for y we call range. And now later on I'll discuss about codomain. Codomain means the values we guess that may come for y, but in reality they may come or they may come not. Okay, now when you consider a small domain 1, 2, 3, now this is a limited domain, and now there will be y, and we guess for y x plus 3 you get these answers 0, 1, 2, 3, 4, 5, 6. We just guess these values may come, but we are not so sure. But however, the values we guess that may come or they may come not, we don't know, but we call them codomain. But actually when you put x equal 1 plus 3, 4, we get 4. When you put x equal 2 here, 2 plus 3, 5, you get 5. X equal 3, 3 plus 3, 6, you get 6. Now these values actually coming. So the values really truly come for y, we call it range. So range means what truly comes out as outputs for y. These are range. Now after that we'll see some 4 special principles we use to find domain and range of a function. Now let's see, you have something squared. In this box there will be a value and that's been squared. You must know that for this inside the box we can put anything. No limitation. We are allowed to put anything, which means you can put any value. Now, since this is squared, you should know that when it's been squared, you definitely will get a positive value for the answer. So now this whole thing will be definitely greater or equal 0. Either this can be 0, otherwise it will be definitely positive. Now then we consider a square root. Now this topic might be controversial, but I will explain it furthermore when I'm doing some questions. Now inside the square root we can't put negative values. Why? Because just remember the definition. Function is a special relationship where each single real input has a single real output. Real outputs. For square root to have a real output, the inside thing should be definitely a positive number, because negative numbers will give imaginary answers. So inside this box it should be greater or equal to 0, and a square root function is always positive. Just keep it in mind. Usually in maths, now just people think that square root is plus or minus. It may get plus answer or negative answer, but here in functions, if it is square root given, remember always it's always positive. Now later on, now just we'll consider modulus functions. In other words, we call them absolute functions, where you get absolute values. Now let's say you put -2 here, you get +2. You get -3, you get +3. You get +5, you still get +5. So whatever you put inside the modulus function or an absolute function, we get a positive value. Now therefore, first of all, inside the function you can put anything. So you can say you can put anything. This is how you put anything. X is real, you can put any value. But modulus functions, you should have always positive. This is greater or equal to 0, because it will never give negative answers. And the last but not least, we consider about the denominators of fractions. Now up you have numerator. Now down, remember in maths, in fractions, we never accept null denominators. So definitely whatever can be gone inside, but this inside never can be 0, because denominator is 0, this fraction become indefined. So in order to have real outputs in a function, we must have some value which is not 0. So always remember, if it is a square, you can put anything, but output should be positive. And in a square root, you should put positive stuff, and you will get also definitely positive stuff. And in a modulus function, you can put inside anything, but it will give the output as positive. And in a fraction, you may get any output, but denominator should not be 0. Now let's look into some examples which we are using these theories in practical problems. Let's look into these 4 examples, and let's see one by one how to find the domain and range of these functions. Now in the first function, which we discussed previously even, we can put any value for x. So domain will be any value of x. What we write is x is a real number. Now to find range, we should do one step, which means we have to subject x first of all. When you subject x, we can write 3 goes other side, which will be y minus 3. Now we see whether we can put any value for y. If we can put any value for y, that means you can have any value for y as outputs as well in this function. So range will be y can be any real value. Moving on to the second question. Now here when we see the domain, what we can put for x, there's no barrier, you can put any value for x. So domain will be any value for x. X is real. But if you remember, when something is squared, it's always positive. So y has to be positive, but before that we have a step to do. Usually we subject x. When you subject x, when you take the square root of y, we put plus or minus in front. Always remember, in a function by default, if it is given a square root, that's always positive. But when we are ourselves manually taking the square root, we are supposed to put plus or minus, because we don't know whether it's a plus value or negative value. Now for y, now here, just in order to have a real output, y has to be positive inside the square root. So range will be y is greater or equal 0. Actually we could notice it at the beginning even, x square is positive, so y should be a positive value. Now in this modulus function question, y equals absolute value of x. Now you can put any value for x, no barrier for that. So domain will be any value of x. X can be a real number. But when you find y, you know here in this step you don't have to subject, because modulus functions can't be subjected for x. So now we can see that modulus x is always positive, so y will be getting always positive values. So range will be y greater or equal 0. Moving on to the fourth example, y equals root x. Now you have to see that now for x we can't put negative values because square root can't give negative values real output. So just square root is giving real outputs only for the real values inside the square root. So x has to be real. So domain will be x is real. I'm sorry, x should be greater or equal 0 because negative values can't be given the real outputs for the square root. So x has to be greater or equal 0. Now to find range you subject x. So x equals y square. Now for this y you can put any real value. That's I agree, you can put any value, but if you remember, for square root always positive values only can be taken. So now y should be positive in this case. This is greater or equal 0. So comparing both incidents we have to come up with a solution. We have to conclude now range has to be y greater or equal 0. That means now here, yes, you can put any value for y, but the thing is at the beginning now root x has to be always positive. So we have to consider both situations, after subjecting x and before x being subjected. Now here y is always positive because square root can't be a negative value in a function. So now it should be y greater or equal 0. Now moving on to the fifth and the last example we are discussing here. Now let's see this example. Fifth question, y equals x plus 2 over x minus 3. Now first of all, now what can be the domain for x? Now x can be any real value. You can put any real value for x for domain, but now we have a problem. Do you remember, for a fraction denominator can never be null, denominator can never be 0. So x minus 3 will become 0 if x equals 3. 3 minus 3 is 0. So you must make sure that x should not be 3. So domain will be x can be any real value, but x can't be 3. So to find range, what you must do is, first of all you have to subject x. Now let's see this function, x plus 2 over x minus 3. Now x minus 3 goes other side, it is y x minus 3 equals x plus 2. So opening the brackets, yx minus 3y equals x plus 2. Then x will be taken this side and minus 3y goes other side. Yx minus x equals 3y plus 2. Then x taken out, then it is y minus 1 equals 3y plus 2. Then x equals 3y plus 2 over y minus 1. Now considering this, you can write range. You can put any value for y, but since denominator cannot be 0, y minus 1 shouldn't be 0. So when y equals 1, y minus 1 will be 0. So y shouldn't be 1. So y is not equal 1. So this is the range. Now in order to practice more questions you can find in the internet, or otherwise I'll be putting in the website later on as worksheets. So practice those questions as well, and I am discussing these questions in order to strengthen my theories, what I'm teaching in my channel. So all the best guys. I'll meet you with the next topic, probably another function or trigonometric lesson. Till then, goodbye.